Hello, everyone. My name is Biniam. I'm a researcher at Nofima in Norway. First of all, I would like to thank the organizers for giving us this platform to share our results. The topic of my talk today is genetic variation for climate change resilience in growth of Atlantic salmon. This is part of an EU project, FutureEUAqua, and the work is done in collaboration between Nofima and Benchmark Genetics, Norway. Just to give you a background information, climate change is one of the major global concerns, and this is no exception for aquaculture. Growth of Atlantic salmon is dependent of the water temperature, and results show that environmental stress can result in growth reduction. One of the major goals of aquaculture industry is to produce robust fish, a fish that can thrive under different environmental stresses. And the presence of genetic by environment interactions tells us if there is a variation in performance under different environments. And that can be taken as a challenge or an opportunity. It's a challenge in a way that if there is a difference, if there is G by E, which means that the performance at nucleus level and at the commercial level is different. And it's an opportunity in a way that it tells us if there is the presence of genetic by environment interaction, then it gives us an opportunity to select for genetic material that can be robust under different environments. Therefore, detection of genetic by environmental interaction will provide valuable information on how aquaculture breeding can prepare itself for future challenges such as climate change. So the objective of this talk is to assess the genetic variation of climate resilience in growth rates in Atlantic salmon. The experiment was conducted in two locations in Norway, as you can see from the graphs. We had two locations in the North Station, which was the GIVAS research station, which was located around Bodø, close to Bodø, in the north part of Norway, and the South Station, which belongs to the Institute of Marine Research, which is located close to Bergen. So that was the selected as the South, and GIVAS station as selected South and North Station. The duration of this experiment was from almost end of October 2019 until August in the North Station, and from end of October 2019 until May 2020. So one of the goal was to get an average of 1.2 kilogram at the end of the experiment. The genetic material used for this study is 75 families from Benchmark Genetics Norway, year class 2019. We had around 4,000 fish, 2,000 fish per family per location, with 135 starting average weight. So the parents of this family were selected based on predicted values for harvest weight, based on traditional ABV and genomic ABV values. And this fish was placed into 2 cages per location, randomly into the cages. And they were fed a marine-based diet, which is similar to the commercial fish diet, but this diet was produced by Nofima. Recordings, we have continuous recordings on, for example, on environmental parameters, temperature, salinity, oxygen, and the visibilities on daily basis, and we have continuous recording on mortalities, the cause of these mortalities, and deformities observed on the dead fish. At the end of the experiment, we recorded body weights, body lengths, and sexual maturity. data analysis. In addition to the end weight, we also calculated the thermal growth coefficient using the initial weight and end weight, and also using the mean temperature, and using this formula as stated in the slide. Quantitative genetic analysis, we use a multi-trait approach to estimate the genetic correlation between the trait measured in 2 different locations using by trait model. For the phenotype we used here, survival, end weight, and thermal growth coefficient at each location as a different. We use genomic relationship matrix to account for the relationship between the fish. And genetic correlation is used to measure the degree of G by E interaction. So we were looking at only the genetic correlation to say about the presence and absence of interaction and the degree of genomic by environment interaction. Results, these are the water temperature, which is the daily average temperature. The temperature we measured at 3 depths in the water, 1 meter, 5 meter, and 10 meter in the water. So this is the average of that daily. So you can see that there is a clear difference between the 2 locations. Just to give you some statistics of the data set, a total of 3,200 fish survived and with phenotype, and the average weight in the south was 950, around 950 grams, and in the north was around 1,580 grams. These are deviated from the target weight, which was 1,200 grams. The main reason factors in the south was that we were taking samples to see the average weight of the fish, and those samples are biased apparently, and also it was reported there was a disease in that region, and due to those and COVID, we could not mobilize our resources to continue the experiment, so it was terminated at that stage. In the north, the fish were grown more than they were. It was projected, and that is contributed for what we observed. Family-wise mortality rates in the south and north, you can see that the mean in the south was 13.6%, and in the north it was 17%, a bit higher in the north. You can see that in both locations, most of the family have few mortality rates. And in the south, there are only few. I think there are few which have more than 20% mortality rate, and in the north also a few families who have more 13% mortality rate in few families. Most of the mortality caused by disease, and some deformities also observed. Now we'll present the genetic correlation in the heritabilities. First, for the survival trait, you can see that the heritabilities are smaller in both cases, and the genetic correlation is 0.61, which shows that there is a re-ranking of families when it comes to this trait. I will talk more about what interpretation of this genetic correlation. For the end weight, we had observed higher heritabilities in both in the south and the north, which is expected for this trait, and the genetic correlation between these location, these 2 traits is very high, which shows that there is a limited re-ranking of families in these 2 different environments. The same is true for thermal growth coefficient. The heritabilities were higher as expected, and the genetic correlation between the two traits into the south and north is also very high, which suggests that there is a limited re-ranking of families. Moving to the concluding remarks, for these two locations, we observed limited re-ranking for growth traits and moderate re-ranking for the survival trait, which means that there is a genetic variation in environmental sensitivity, which in turn means that there is a possibility to select breeding for climate resilience to create robust fish that thrives in different environments. Finally, I would like to thank each and everyone who take part in this experiment, start from designing, following up, and measuring at the end of the experiment. And thank you for listening.